Now we have to get expression for the current. Go back to thermal conductivity. Here, along with this, we'll discuss the drift speed, electric field, all other quantities. So whenever you enter into the inside the conductor, don't just bother resistance. All the parameters of Ohm's law, relaxation time. Of course, relaxation time depends on material here. Let's not bother. The drift speed, electric field, current density, the resistance of different parts, different sections, power dissipated per unit length, all the parameters you have to compare at various points. So how to find out the resistance of this? So I'll assume a small element. So let this be the small element. So radius of this, let it be r. Thickness of this, let it be dx. So let it be at a distance x, I'll assume. Then what is the resistance of this small element? Let it be dr. So how to define? Now you can ask questions. Why you assumed thin disk? Okay, let's come back to the current here. So current I will flow now. So here the current density will be directed in this direction. Then how you should assume always the elemental structure should be such that the current, it should be the area of cross section of that should be directed normal to current density, because everywhere the current will be flowing along this direction. So how the current density will be along x-axis. So perpendicular to j bar, the elemental structure should be assumed. This is one basic rule. So what is the resistance of this small element? dr should be equal to rho dx into area. Area of this is pi r square. We can't integrate directly, no? So I should bring the terms. So you look at this triangle b minus a, b minus a, this will be, and this will be r minus a. This is x, this is theta. We'll agree this triangle. So tan theta from this, I can write it as b minus a by l equal to r minus a by x. So what is r is equal to? B minus a l x plus a. I'll differentiate this. dr equal to b minus l into dx. Let me replace the dx term in the above equations. So dr equal to rho, dx will be L by b minus a into dr by this is pi r square. So rho L pi b minus a r to power of minus 2 dr. So the limit will be from a to b. The radius at one end is a, at other end it is b. So we'll get rho L pi b minus a minus 1 by. So this will be rho L so therefore what is the effective resistance will be rho L by AB. So this is a resistance of this particular given conductor. Let's come for the quantities. What will happen to current density at 0.192? We will just compare here. Current density is at 0.192. One by one we'll compare it here. At 1, current density, area of cross section at 1, it is less compared to 2, no? A1 less than A2. And what is the expression for current density? Current by area, same current will flow, because the reason 1 and 2 are in series, the structures will be in series. So therefore J1 greater than J2. What about the drift speed? J equal to current density is directly proportional to drift speed, no? So the drift speed at 1 will be greater than that at 2. What about electric field? J equal to E by rho. So E1 should be less than E2. What about the resistance of elements? Resistance of elements, where area of rho L by A. Rho L by A, where area of course less, they're more resistance. So R1 greater than R2. Provided similar elements I'm picking up. Let me give one rough diagram. These are the two identical elements we picked up. So sorry, of same thickness we have picked up, then we are comparing them. This element 1, this element 2. What about the power dissipated in those elements? The when where current is same through them, where resistance is more power. So P1 greater than P2.
How did you get the relationship for E, sir?
J equal to E by rho, no? This should be greater. Because same resistivity, no? The material will have uniform resistivity. Can you say anything about potential differences? Potential difference. So what is the expression for potential difference? E
V1 greater than V2.
E1 greater than E2. So same dx in that. So delta V1 greater than delta V2. So every numerical, irrespective of shape, I took here truncated cone or tapered rod. What is this? Resistance of a tapered rod. What we calculated is resistance of a tapered rod or truncated cone. So in every, so don't forget this, because this part is what the conceptual, which will help you a lot in numericals, especially more than one options. Along with this mathematical things, they'll include these things. So if you work out some 2-3 different shapes, no, you'll get overall picture. Okay, this is what I should do. Rather than fighting with concept, no, make a practice of this one. Different shaped conductors, not just finding out the resistance, you should compare all the other parameters that are related to Ohm's law. What are other parameters? Like a disk speed, current density, electric field intensity, then whatever the resistance of that elements, potential difference across the elements, power dissipated. Okay, fine. So I'm making it a rule. Just practice few, it'll be in better position. Because you see in EDO, in few problems is asking these things. What will happen to? So students will think something conceptual they're asking. No, it's everything through mathematics we should conclude here, not something like we have to make a guess. Got the idea, no? So anything if they ask you something, so assume the basic equations you have, apply them properly. Okay, similarly, we'll go for spherical conductor.